convert the D flip-flop to the T flip-flop. So if we have our D flip-flop, we're going to start with the truth table. And our truth table looks like, so if the clock, I'm going to say triggered on the PGT, so for positive going transitions, oops, what am I doing? Okay, go away. Okay, the D input, every time there is a positive going, so we'll just say PGT, then our output Q is going to be 0. It just follows whatever D is. So we're going to take that and we're going to make our characteristic table. Oh, go away. Thank you, go away. Okay. Oh, that's really messy handwriting. I apologize. We'll do large eraser. Okay. Yeah. Our characteristic table. All right, so our characteristic table is going to look like this. So Qn, we're going to have input D, and so what we're going to have, that's not a good line, okay. And then Qn plus 1. Okay, so we're going to have 0, 0, 0, 1, 1, 0, 1, 1, and then Qn plus 1, so Qn, so if it's 0 and it's 0, so it's just going to follow D. So this will be 0. This will become 1. If Qn is 1 and then D is 0, we're just actually following D. So that's not really a big deal. And so we're going to make our excitation table out of this. So our excitation table. So that's going to relate the states, the output states Qn and Qn plus 1 and D. All right, so basically we're just rearranging our characteristic table. So 0, 0, 0, 1. Oops. Back to pen. 1, 0, and 1, 1. Okay, so at 0, 0, this was from D is equal to 0. Qn equal to 0 and Qn plus 1 equal to 0 happened when D was 1. Qn and Qn plus 1, 1, 0, that happened when D was 0, and then 1, 1 happened when D was 1. Okay, so we are going to remember that. Hope you have this in your notes because I'm about to erase all this. Yep. Okay, we want the T flip-flop. So let's draw the truth table for the T flip-flop. So basically the T flip-flop is a toggle. So on the clock, so on the PGT, we have our clock transition. This is T, this is Q. You can say this is Qn plus 1. So every time there's a positive transition, if T is 0, then we'll just get whatever Q was before. So this is our memory. If T is 1, it's going to toggle. So we're going to get Qn bar. So this is just our toggle state. All right, so let's draw our characteristic table. So characteristic table, that's going to be, and I'm actually going to draw it like this. I'm going to draw the T first and then the Qn. And then we'll have the Qn plus 1. So 0, 0, 0, 1, 1, 0, 1, 1. That looked a little prettier. All right, so when toggle is 0, we're just going to get, that's just our memory state. So we're going to get 0 and 1 back. Now it toggles when T is 1, so Qn is going to turn into 1, and it's going to turn into 0 here because we're toggling. Okay, so that's the basics for what we want. So now we're going to use these tables for both the T and the D flip-flop to draw our stuff. So I'm going to erase everything again. All right, I'm going to rewrite the characteristic table for T. So we have, I'm erasing that. So back to pen. All right. Characteristic table for T. This is what we want. And I'm going to rewrite it in that way. So I'm going to have T first. I know in the last notes with the JK flip-flop, when we're converting the JK, I did this, but it's going to turn out easier to see what we're doing if I do it in this order. All right, so 0, 0, 0, 1, 1, 0, 1, 1. And we said that was 0, 1, 1, 0. Okay. So over here, I'm just going to draw the excitation table for D really tiny. So the excitation for D, so that was what? Qn plus 1, and D over here. So 0, y'all can't see that. Let me rewrite that. So the excitation table for D, so it was Qn plus 1, and then we had D, 0, 0, 0, 1, 1, 0, 1, 1, and that was what, 0, 1, 0, 1. Okay, so basically what we're doing is we're going to transfer, let me pick a different color. We're going to transfer this stuff over to here. Let me go back to purple. Maybe I'll write it in green. Okay, so we're gonna have D right here. So basically we're taking like this chunk of the table and we're transferring it to this side of the table. So this side of the table right here. Okay, so what do we have? So we have to look because this is in a different order. So this is 0, 0. So 0, 0, that gives D is equal to 0. Now this one is Qn is 1 and Qn plus 1. Is 1, so we're going to look at this entry. So so that's going to give us D is 1. 0 and 1 gives us 1. And then 1 and 0 right here gives us 0. So we have to write our excitation table for D in a different order. And that was probably what was tripping you guys up. All right, I'm going to erase this part. Okay, so back to purple. It's a 0. Okay. Eraser. All right. All right, so now we can make a K-map out of this. So we're going to compare these inputs right here. So these inputs to the D output, because go back to pen. Yeah, that's what I want. Okay, so we're gonna have Qn bar, Qn, T bar, T. Okay, so when does 1 happen? 1 happens at T and T in bar and Q in, and it happens at T and Q in bar. So we're going to put a 1 here and a 1 here. Does that work? Did I do it right? T, yeah, looks like it. Okay, 0, 0. Okay, so these aren't really a pair or anything, so our expression for D is going to just be Qn T naught ORed with T Qn naught. Okay, that's our expression for D. Does this look like anything we've done before? So, and also this truth table should tell you this looks like an XOR gate, so exclusive OR. So we can rewrite this expression as Qn XORed with T. So that's our expression for turning the D flip-flop into a T flip-flop. All right, so if I erase stuff right here, what's that gonna look like for my flip-flop? All right, we're starting with a D. Okay, so you have D right here. You have some clock input right here, and then Q output right here. All right, so we have D. We want to input T. I'm gonna give myself plenty of space. So what's gonna happen is this is going to be XORed. So we're gonna have Q coming back around. And actually, this input has to be, oh my gosh, I'm just gonna start over. Okay. D flip-flop, Q output. This input is gonna come in and there's gonna be an XOR gate going into the D, and then we can put a whole box around this. So our output, our new input for D is going to be whatever T is, XORed with our output for Q. So that's how you draw it. I think in the lab, it wants you to do all the gates. So you would have to draw the D, instead of drawing a box for D, you'll have to draw it with gates. So, all right, that's it.